Hi guys, welcome to my video tutorial on programming programming using Python. So what I'll be doing in this video and a series of videos that will come after this is to help you write code in a systematic incremental way so that you can tackle problems. You can write code. You get a feel of how to go about writing code for programs. So most people have difficulty, like they can understand the algorithm, but when it comes to writing code, they find it difficult. So I thought I will make these video tutorials so that it will be helpful. So in this video tutorial, what we'll do is we'll uh, discuss write code for Fibonacci numbers. So Fibonacci numbers Fibonacci numbers is there are two uh, ways that you can represent Fibonacci numbers. So one way of doing that is you generate sequence like 0, 1, 1, 2, 3, 5, 8, and so on. So if you look at the sequence, you'll find that in Fibonacci sequence, after the first two terms, all the rest of the terms is the sum of the previous two terms. Like the third term here is 1, which is the sum of 0 and 1. The fourth term is 2, which is the sum of the third term and the second term. So Fibonacci sequence we usually represent using a recursive definition. So if you want to find the nth Fibonacci number, then if you represent the nth Fibonacci number as f of n, then that will be equal to the sum of the two previous numbers in the sequence. So if the nth term, the previous term will be the n minus 1 term, and the term previous to that will be the n minus 2th term. So that's n minus 1 term and n minus 2th term. So to find the nth term, you have to add this term and this term. So if I represent the n minus 1 term as f of n minus 1 plus the n minus 2th term as f of n minus 2, then that's the recursive formula for finding the nth Fibonacci number in the sequence. So what we'll be doing is there are two problems here that you can write code for. One is that to find the nth Fibonacci number. That's one problem, and the other problem will be to uh, display or display the Fibonacci sequence. Display the Fibonacci sequence up to a particular value like n. So, okay, if you the code for this problem, the output will be like if you give n as 5, it should output the fifth number in the Fibonacci sequence, which in this case will be 1, 2, 3, 4, 5. So if you give n is equal to 5, it should output 3 as the 3 as the it should give 3 as output, right? Okay. So in the for the other problem where you have to display the Fibonacci sequence up to n, you'll be if you give n as 5, your output should be 0, comma 1, comma 1, comma 2, comma 3. So you have five numbers. So 1, 2, 3, 4, 5. So that's the this and this. So this is the input, this is the output. Here, this is the input, and this is the output. So this is what we expect from a code to output in each of these two different problems. So let's go ahead and see how we can write code for this. So let me clear this page. Okay, so in Python, what you're going to do is write a function called, so a function for Fibonacci numbers. I'm going to call it uh, fib. That's the name of the function. So in Python, we define functions by its keyword def, and the name of the function will be fib. And as you know, a function is something which takes arguments. Uh, it can take arguments. It can also not take arguments. But for this particular Fibonacci function, what we are going to pass as argument is n, which is the nth Fibonacci term for the first problem. So let's first deal with the first problem and then go to the other problem. So what in this problem we are trying to do is output the nth Fibonacci number. So when you call this function fib to perform the task, you should give that function what you expect. Like I have to tell that function that I need the nth Fibonacci number in the Fibonacci sequence. So fib is a function. We have defined it using the def fib, and then n is the nth Fibonacci number that I want to display. Now in Python we put colon after the function definition of the function. We put a colon, and then as we know we have to indent it to the right. So here in this part we'll write the definition of a function. So let's think about this. So if you want to find the nth Fibonacci number, like if they are if the input is 1 or 2, right, which means you want the first Fibonacci number or the second Fibonacci number. We don't need to calculate that because the first two numbers are fixed. It's 0 and 1. So we just need to, if the input is 1, we just need to return 0, and if the input is 2, we just need to return 2. So that's the case where we just need to check what n is, right? If n is 0 or if n is 1, then we can just, sorry, if n is 1 or n is 2, then we can just return 0 and 1. So I'll put an if condition there. So this is what it will look like. So if if n is equal to 1, which means I want the first term of the Fibonacci sequence, then all I have to do is return 0. So what I'm doing is I'm returning 0 to the person who called fib, right? So that he can print 0. Okay, now if it's not 1, if it's 2, then what do I have to do? So L, if it's not 1, now if it is 2, which means I want the term that I want is 1. So I have to return 1. So return 1. So what I'm the systematic way that I'm talking about is called incremental development. So first you deal with the easy things, and then you to go on to develop the solution for the more complicated cases, right? So these are easy cases. When this, if I now call this is definition. So like if I want to call this function, I would call it here, right? Like I would say fib. I'll call fib. Let's say if I call fib one, right? This program will return 0, right? So if I call fib one, control goes here, with 0 as input. So it checks if, sorry, n as 1 as input. It checks if n is 1, it returns 0. So this function gets the value 0. And if I want to now print it on the screen, all I have to do is print whatever comes back and we'll get 0 on the screen. The same thing happens if I change the argument to 2. If I now pass 2, uh, which means you want the second term, right? So this will become 2. And now when it checks n is 1, this is not true, so it skips this. Now it comes to the elif case. It checks n is 2, so it returns 1. So this gets 1, and 1 will be printed onto the screen. So these are the easy cases that we can easily deal with. Now to get from the third term onwards, we'll have to use the recursive formula. So this video is getting longer than I expected, so I'm going to continue this in the next video. So if you like this channel, please subscribe to this channel and follow so that you get notifications about the new videos that I'm going to upload. And if you are curious as to how to write the next section of the code for this Fibonacci sequence, please watch my next video. See you there.